We have measured the age of the universe to within 40 million years. We have photographed a black hole. We have listened to gravitational waves from colliding neutron stars a billion light-years away. And yet, hidden inside the notebooks of serious physicists, there are ideas so disturbing they rarely leave the room. Not pseudoscience. Real, published hypotheses that quietly suggest reality itself might be a mistake, a flicker, a countdown. 10 of them, rising in dread, ending with something that could already be racing toward you at the speed of light. Subscribe and let's open the drawer they keep closed. It starts with a piece of math so simple it feels like a trick. In 1983, astrophysicist Brandon Carter proposed what philosopher John Leslie later called the Doomsday Argument. The idea is this: roughly 117 billion humans have ever lived. You are statistically somewhere in that list. If humanity spreads across the galaxy and lasts 1,000,000 years, your birth number should sit near the very beginning of a trillion-strong species. It doesn't. It sits close to the middle, which means, by pure probability, humanity is closer to its end than its beginning. This is a hypothesis, not a proof, but the physicists who work on it are not joking. And it gets worse, because the next theory says you might not even be a real person reading this. In 2002, cosmologist Carroll and others began seriously discussing something Ludwig Boltzmann had hinted at over a century earlier. In an infinite, high-entropy universe, random particle fluctuations will occasionally, by accident, arrange themselves into a fully formed conscious brain. A brain with memories, thoughts, and the feeling of reading these words. Then, seconds later, it dissolves back into chaos. The disturbing part is the math. In an infinite cosmos, these Boltzmann brains vastly outnumber real evolved observers on real planets. So statistically, if you exist, you are more likely a hallucinating fluctuation than a human. Cosmologists call this the Boltzmann brain problem, and they consider it a serious warning sign that our current cosmological models are broken. And if your existence is that fragile, what does it say about reality itself when no one is watching? In 1998, physicists Anton Zeilinger and colleagues published a version of the double-slit experiment that erased any doubt. A single particle behaves like a spread-out wave when no one measures it, and like a solid dot the instant you do. Repeated thousands of times in labs from Vienna to MIT. The mainstream reading is that quantum systems have no definite value until measured. But a small group of physicists, including John Wheeler, who coined the phrase participatory universe, argued something stranger. That the universe itself may have no fixed state when unobserved. That the moon, in some radical readings, is not really there in the same way when nobody looks. This is a controversial hypothesis, not consensus, but if reality only crystallizes under observation, what happens in the vast dark parts of the cosmos where no one is looking and what might be looking back? In 2008, Chinese author Liu Cixin published a novel that quietly captured a hypothesis astronomers had been whispering about for decades. It is called the dark forest solution to the Fermi paradox. The sky should be loud. There are an estimated 100 billion stars in our galaxy alone, many billions of years older than our sun. Yet after 70 years of listening with radio telescopes like the Allen Array and FAST in China, we hear nothing. One proposed answer, taken seriously by researchers like David Brin, is that every advanced civilization stays silent because announcing yourself is suicide. In a universe of unknown intentions, the safe move is to shoot first. And Earth has been broadcasting radio into space since 1901. Our signals have already reached over 10,000 stars. We are the ones shouting in the dark forest. And what if silence is not the worst answer to why we are alone? In 1996, economist Robin Hanson at George Mason University proposed the Great Filter. Somewhere between dead chemistry and a galaxy-spanning civilization, there is a barrier almost nothing survives. If the filter is behind us, say, the origin of life or the jump to complex cells, then we are rare and safe. If it is ahead, then every intelligent species, including us, hits a wall it cannot pass. Nuclear war, engineered pandemics, runaway AI, climate collapse. We have found no fossils of alien civilizations on Mars, no ruins on Europa, no Dyson spheres in Kepler data. Every silent star is another vote that something up ahead kills everyone. Hansen himself has said the more Earth-like planets we discover empty, the worse the news. And speaking of things that repeat until nothing is left, the next theory says you already have. Friedrich Nietzsche called it his most terrifying thought. Modern physicists call it Poincaré recurrence, first proven mathematically by Henri Poincaré in 1890. The theorem says that any closed system with finite states, given infinite time, must eventually return to every configuration it has ever had, arbitrarily closely, arbitrarily often. If the observable universe is finite in its possible arrangements and time stretches forever, then the exact atoms of your body, arranged in the exact posture you are in right now, watching this exact video, must recur. Not once, infinitely many times. Every mistake you regret, every person you have lost, replayed with perfect fidelity forever. Cosmologists debate whether the real universe qualifies. Dark energy may prevent it. But if it does, immortality is not the escape from suffering. It is the trap. And there is a way out, if none of this is real to begin with. In 2003, Oxford philosopher Nick Bostrom published a paper in Philosophical Quarterly with a simple argument. If any advanced civilization ever runs detailed ancestor simulations, virtual worlds populated by conscious beings, then simulated minds vastly outnumber biological ones. So statistically, you are almost certainly inside one. Elon Musk has said the odds we are in base reality are 1 in billions. Neil deGrasse Tyson puts it above 50%. This remains a hypothesis, not a fact. But here's the part that keeps people awake. A simulation is code. Code can be paused. Code can be deleted. If our reality is a research project running on some future machine, then our extinction does not require a supernova or an asteroid. It requires a board operator, a power cut, or the end of a grant. There would be no warning. One frame you exist, the next you never did. And there are ways the real universe could end that are almost as fast. In 2003, physicist Robert Caldwell published a paper in Physical Review Letters describing what he called phantom dark energy. If the mysterious force accelerating cosmic expansion grows stronger over time, and current data cannot rule this out, then everything ends in a scenario called the Big Rip. First, in about 22 billion years by some models, galaxies would be torn from each other faster than gravity can hold them. Then, in the final minutes, the Milky Way would fly apart. Then, the solar system. Then, Earth itself would shatter. In the last fraction of a second, atoms would be pulled into their component particles. Space itself would be stretching faster than light between any 2 points. This is a possible fate, not the certain one. But the DSI survey in 2024 reported hints that dark energy may indeed be evolving. And if the Big Rip is loud, the mainstream ending is silent, and somehow worse. The consensus fate of the universe was worked out in the 19th century by Rudolf Clausius and refined by modern cosmologists like Freeman Dyson in 1979. It is called heat death, or the Big Freeze. In roughly 10 to the 100th power years, a 1 followed by 100 zeros, every star will have burned out. Every black hole will have evaporated through Hawking radiation. Every particle will be so far from every other particle that no interaction can ever happen again. The universe becomes a thin, dark soup at absolute temperature, not destroyed. Just permanently, mathematically incapable of anything ever occurring. No memory, no motion, no time in any meaningful sense. This is the mainstream prediction. The optimistic one. The one taught in undergraduate courses. And it should tell you something that heat death is the good ending, because the last theory is the one physicists genuinely lose sleep over. In 1980, physicists Sidney Coleman and Frank DeLucia published a paper in Physical Review D that has haunted cosmology ever since. It described false vacuum decay. In quantum field theory, the vacuum of empty space has an energy value. Ours may not be the lowest possible one. It may be metastable, like a ball resting in a shallow dip on the side of a mountain. In 2018, a Harvard team led by physicist Anders Andreasen calculated, using the measured mass of the Higgs boson from CERN, that our vacuum is almost certainly metastable. Somewhere, at any moment, a tiny bubble of true vacuum could nucleate through random quantum tunneling. Inside that bubble, the laws of physics rewrite themselves. Atoms cannot exist. It expands outward at the speed of light. Because it moves at light speed, no signal, no warning, no light from its edge can ever reach you first. One instant you exist, the next you were never possible. It may have already begun somewhere in the observable universe. We would only find out when it arrived, and it would arrive at exactly the moment it ended us. 10 ideas. Every one of them published. Every one of them defended by serious scientists at real universities. None of them proven, but none of them refuted either. This is the strange truth of modern cosmology. The more precisely we measure the universe, the more terrifying the possibilities become. And the quietest theories are often the ones physicists mention only over coffee, never in press releases. So tell me in the comments, which of these 10 keeps you awake tonight? The one where you are a flicker of chaos? The one where the sky is silent because it is hunting? Or the one already racing towards you at the speed of light?